multiplication, division, modulus is just the remainder, and then exponentiation. And with exponentiation, you can also pass in like decimal values to get the square root and like cube root and stuff like that. And then you have strings, which is just words or like characters or text. So variables, giving something a name. So like apple. So we would say that apple is an apple. So variables in Python, to assign something, you put the variable name and then the value. So in this case, we have first name, which is Joe Schneider, and that's pretty much a string that we wanted to store. And then we have a score, which is equal to 19. So in Python, you can just put the name of whatever the variable you want it to be and just assign it like that. And then how do you actually get the value back out of the variable? You can just call or put your variable name. So if you were to say first name again, you would get Joe Schneider, or if you were to just put score, you would get 19. So when you're actually naming variables, you should definitely give them meaningful names, because usually you're going to be storing information that you want to get back later. And if you just have like random names that you don't memorize, it'll be like your code will be really clunky. So you shouldn't give this dog the name Flaming Dragon Slayer. So input and output, talking with the program. So input is giving the program some information. So this is sort of like how you're talking to the program or telling it what you want to do. So, the program may ask you, what is your name, or where are you from? And to do something like that, you'll use something like this input, where this is what the computer will ask you, what is your name? And so that's the question you think. And then in your interface, which will use be your command line or your terminal prompt, you would enter something like Kimberly Smith, and that would be the answer that you would give your program. So that's sort of like a basic way to actually talk to Python. And then output is getting information from the program. So with output, that's pretty much what the program is actually telling you back. So something like Packers 31, Bills 3, or your balance is $1,986. So to do this, you use a statement like print, where you would pass in a variable, which would be like something like account balance or something that you store in your program that has the information of your like number or your balance of your credit card. And then your interface would give you back, oh, you have $1,986. So list and container. So list is pretty much a container which you can store a whole bunch of different types of values. So in this little example, we have pretty much just a grocery list here, and this would be the list syntax where we have all these different like words, which would be bananas, apples, fish, eggs, and milk, that we wanted to actually like put into our list. And if you can see, they're like just comma separated values. And to make a list, you use the square brackets in Python. And if you want to get any items out of the list, you pretty much just call the variable name that we have, which is a grocery list, and then to get a specific item, you would call whatever indices. So in a list, the indices start at 0 instead of 1, so the first item, bananas, would be at grocery list 0, which is bananas, and then grocery list 1 would be apples. And so you can sort of just go through every single index and get the individual ones. So for loops. So for loops are doing something for a certain amount of times. So like in track, you would go for 400 meters, you do 1 lap, 800 2 laps, 1600 4 laps, 3200 8 laps, etc. So in Python, you can have something like a list. We have this grocery list. And let's say we want to get we want to print out, or we want the program to tell us what, like, every single item which is in the list. So we can do something like, using a for loop, we can do for item in grocery list, which is pretty much saying for every single item in this list, just print this item. So the result would give us back that we have bananas, apples, fish, eggs, and milk in our grocery list. So the way this actually works, if you've been in a different programming language behind the scenes, pretty much this syntax will do the same thing as putting in the index for you. So pretty much where we have this grocery list 0, it'll pretty much be doing that on the fly in the background and pretty much putting that in. It's not exactly how it works, but it's pretty much, or that's sort of what it's doing. So like you said here, item is a variable set to each thing in the grocery list, sort of like item is equal to grocery list at 0. If else, or conditionals. So it's like a yes or no question, or in computer science terms, true or false. So did you make your bed today? So a conditional is the basic if statement, which is what you want to actually know the answer to. So is number modulus 2 equal to 0? Then print the number is even. Else, print the number is odd. So it's just pretty much this true or false statement. So if you were to pass in the number 3, it would be say the number is odd, else the program would say the number is even. Then you can also add multiple conditional statements by nesting these else statements. So if the temperature is over 105, it's scorching hot. If the temperature is over 90, it's hot. Essentially. And then these are all the Boolean operators that you can use to actually check for true or false statements, or at least some. So functions. Functions are a collection of tasks to be done together. So traditionally in math, a function will look like y is equal to f of x plus 3, or y is equal to 5 times x plus 3, or f of x is equal to 5x plus 3. So the task that this function is doing is pass in a value for x, let's say that it's 3, multiply 5 times that value, which is 3, and then add 3. So the result is 15. So it's just a list of tasks that you want the program to do in order. So we can represent this in Python by doing something like this, where we made this function called evaluate, which takes in an x variable, which would be like a number, and then we have this print x, so we just want to see what the number that they passed in, and then return the result. So when looking at this, the def keyword is used to declare the function, and then the return keyword to give us the result and store it into a variable. So after we do a value 3, you'll get the result, or we'll store 18 into the result variable. I also should note the syntax that Python uses. Whenever you're using a function or a for loop or going into a different scope, you should always indent at least, or you should either tab or use spaces to indent your actual code, and every single thing in that little block should be on the same tab level or space level. So as you see here, we have this def evaluate, and then every single thing that's in the evaluate function, we have on this line. And then, no, you don't have to return values in functions. So if you have something like, we made a function now that's def even, which takes in the number, which number modulus 2 is equal to 0, print the numbers even, and then else it prints it as false. We don't really need anything from that function. You're not actually looking to store any values, so there's no point in doing it. And so functions are really good when you want to perform the same operation or task multiple times in your program. And so instead of writing it out a whole bunch of times, it's better just to define it in one place and then just call that function to use later. And then it also makes code more readable, having it just in one spot. And then modules is pretty much a collection of variables, functions, or classes that can be embedded or integrated into your program. So it's pretty much just code that you didn't write, but somebody knew that you probably were going to use it, or it's like a task that a lot of people use. So it's just like having this there so you can easily just use it whenever you need it. So to import a module from the standard library, you can just do something like an import map. And then so if you were to call map.py, which is saying from this module, I want this pi variable, it would give you the pi, or pi's value, well, approximation of pi's value. And then if you were to do a function from a module, you would do map.gsd and then pass in whatever parameters that the function actually takes. So in this case, 1927, and then you get 9. So good resources to get started in Python, or really good tutorials when you're actually just starting to learn, or you have a question. Python Anywhere allows you to actually code in Python without actually having to use a text editor or your command line, or you don't have to have Python actually downloaded. So if you just want to try it, or you have something that you need to get done fast, you can use that. Code Academy, they have a whole bunch of different tutorials on introductories to getting into different programming languages, so it's a good place. And then PySchools is directly for Python. It's sort of like Code Academy, but they have some challenges that you can also do using Python. Python challenges, there's Python mini projects, so if you...
Python Everywhere, you can also host a project, so if you make something super cool and you want to show your friends, it'll serve them an instance for you, and as long as you kind of check how you can speak. You can do it for free as long as it's tiny, and every 6 months it'll say, hey, you need to turn me back on or I'm shut it down. So if you've got a cool little project and you want to show it to some people, or you need something that can actually run the language for you, it's a great resource.
For challenges, so there's Python mini projects. It's pretty much just some small little snippets, or pretty much challenges. So maybe it's just if you want to do something, maybe make an alarm system on your computer, which will pretty much wake you up at a certain time, or just opening up your local host and putting up some hello, or some little website. So you can do sort of things like that. Code Wars gives you more of challenge for makes you think. So it's not actual real life problems, but it's more small tasks that they want you to perform. And then Check.io is sort of the same thing. They have a really cool interface. And then online free books that you can use. Learn Python the hard way. I don't think that the name suits it really well. I think that it's actually a really good resource and an easy it's actually easy to actually it's an easy read and it's really helpful. I usually use that whenever I have a small question in Python syntax that I don't remember. Python guides is a really good source. And then dive into Python 3. I know that the last time we did one of these introductory talks, they were given the book, and that's pretty good as well. And then if you want to get into web development, the Django Girls has a really good tutorial. They're awesome. They have they have pretty much a huge group that actually provides pretty much resources, strategies, and tries to get girls into Python development and pretty much web development. So yeah.
Does Python do type coercion? So, example, if I had an if statement, something like if number 5 less than string 5, would it be smart enough to know, oh, those are both numbers? That's how I should do the comparison.
No, it's number 5.
Like if I have a 5 that's a string on one side, 5 is a number.
You would have to cast it as a. So Python. So you saw how we had a string and then like a number. He was asking whether or not if you had like a 5 in like the string, it would know that it's a number. But the answer is no. You would have to like use a helper function or something for your standard line.
Multiple strings.
He wants to check whether it's a.
Just a comparison.
Yeah, you want to do a comparison if like a number 5 is equal to a string 5. So yeah, like he said, you'd have to convert them both to a string or convert them both to a integer.
So Python's an interpreted language?
It's a scripting language.
Okay.
Yes.
So is there a way to package up and distribute
Yes.
Python code
Yes.
Yes.
without having to have someone download the interpreter or the...
Yeah. Well, they would have to run or have Python on there. Well, actually, no. You can actually just run a full program. They would just have to yeah.
There are ways of compiling Python.
Yes.
It's done often first by transpiling it into another language such as Go.
Any other questions or anything that you want me to go back and like explain in the slides?
How big can a number be?
Infinite.
Can it?
It keeps growing. Yes, it can. You do need to have the memory to hold that number, though.
Yeah, that would be like yeah. So Python, it just has like the standard like types or like has the standard types, and if you want to go deeper into writing or measurement for like if you want like a 32-bit integer or a 64-bit integer, you have to like download import like NumPy to even specify those amounts.
How does it manage memory? Is it like a garbage collector or?
So because it's like the scripting, or it sort of just handles it all in the background. You don't really mess with numbers at all, so you should be good.
So you don't worry about scope of memory, just figure out that.
Yeah.
So like Abby said, so like let's say you had a really hard number, right? And let's say you're more advanced in Python, would you be able to just create a program where it remembers an abnormal number you may use and just like put it into a file so you don't really have to remember it?
So yeah, there's like you can actually you can read files and just like you can pretty much take like whatever like your program, you can pretty much store it into like, or like if you want to have like a program that has like an input and output file, so if you like have like all these results and you just want to store it in the output file, you can totally put that, and then the next time when you run the program, you can just go to that file and get that number back and just place it right back into your program.
Do you know any good resources for like learning or importing or whatever for like web scraping?
Beautiful Soup. Yeah. There's a library called Beautiful Soup. It's essentially a very simple but powerful HTML to some form of code where you say, I want this, or you give it an HTML web page using something like URLlib, which is a URL handling library, and it goes through, it parses it, and you say, okay, I just like jQuery, I want all text and elements that look like this. It'll do that.
But really make your request and request.
Yeah.
Yeah. So yeah, I'm working to that, and then URL is a writing font, and you can use it to actually open up. Any other questions? Cool. That's all I had. So thanks.
Thank you.